Hello, these are the solutions to exam 2. Okay, we have a function here. We need to do several things on it. In fact, we probably need to do even more than this, like find the intercepts and end behavior if we want to graph it. But let's start with these 4 things that we're specifically required to do. Now, as soon as I see this, I'm going to try to factor it, and if there would be any common factors on top and bottom, I would cancel those out, but make note of them because those would imply a whole, which we'll get to here in just a bit. So part A, we noticed that we can't have x equals -6 or 4. We can have any other possible number, real number that you would imagine down there, except for those 2 numbers. So we have to pull those out of the domain. And also that tells us, because we're not getting those by canceling a factor, there's not an x plus 6 on top, for example, both of those are going to give us vertical asymptotes as well. Now in part C, because we didn't cancel out any factors, there's no holes. And part D, because the power, the degree of the numerator, is less than the degree of the denominator, we do have a horizontal asymptote at y equals 0. Of course, there's 3 different situations that could have occurred there. Your book talks about them. Okay, x-intercept. The only way that this entire function would equal 0 is if x equals 0. And if x would get plugged in, if we'd plug 0 in for x everywhere, we would get 0. So the x and y-intercept are both 0, 0. End behavior, we can plug large numbers in there and see that y does go to that asymptote of y equals 0, that horizontal asymptote. And then by noticing, I guess we could start by plotting those asymptotes, plotting the intercept there, and then we could, how would we know if we're coming in on this side or coming on this side? Well, we just look, what's a number that's just a little above -6, maybe -5.9. If we plugged -5.9 in here, we'd have a negative on the top. This here would be a positive, and this would be a negative. So we'd have a negative times a negative, or negative divided by negative would give us a positive. So we're going to get higher and higher positive values. And we could do that in each of these cases to figure out which direction we're coming in from. Okay, on number 2, we can do kind of the obvious here, multiply both sides by x squared minus 9. The thing we do have to be careful about there is, well, for one, when we have 18x here and a -18x, a lot of people cancel those out. It wouldn't work that way. So we could either combine them for positive 36x over here or negative 36x here. Once we get to this x cubed minus 12x, we could factor out an x, or we could put the 12x over there. Either way, we'd like to divide by 0. Oh, sorry, we would not like to divide by 0. We'd like to divide by x, but we have to keep in mind that x could be 0. So we put in x equals 0 as a possibility. And once we've reserved that possibility, now we can go ahead and think of all the other cases where x is not 0. In any of those cases, we can divide both sides by x because it's not 0. And then we get 12 equals x squared, which would give us x equals plus or minus square root of 12. And again, we're taking the square root of both sides, so we do need to do the positive square root and the negative square root. And it says be sure to check for extraneous solutions. What does that even mean? Well, it's possible using this method that we would get a solution that when we plug it back in here would not be a real solution. In this case, all 3 of these values work out, so all 3 are solutions. But we will have some, while we're on that topic, we will have some extraneous later in the exam, so I'll mention those. Okay, I think there was a little confusion here. 2 non-identity functions. The 2 functions were f of x and g of x. You didn't have to come up with 2 pairs of functions, but if you did, I didn't penalize you for that, of course. So f of x here, and perhaps easiest way would be to just let f of x equal x cubed, and then g of x equal 6x plus 1 over x minus 1. Notice that you do have to have those x's there. If you just have 6 plus 1 over negative 1, that's just negative 6. That's a constant horizontal line. But here, when we plug in our f of x into our g, we plug in x cubed every time we see an x, and we'll get exactly what we wanted to get. Okay, on this one, a lot of people got the fact that you put in y for f of x, and then you switch your x's and y's. Somewhere along the line, a lot of people made algebra mistakes, but you should end up with this inverse function right here, noting that x cannot equal a, although I didn't take off points for that. Number 5, this was a challenging one. So the issue is how to deal with this 2/3. First of all, we cannot distribute it to both of those. Just like a squared term would have a middle term, anytime you have more than one term inside of parentheses raised to a power, we can't just distribute that power there. Now what we can do is we can kind of cancel it out by multiplying by its reciprocal. So if I raise this to the 3/2, 2/3 times 3/2 will just be 1, so I can just basically remove the power then. In order to do that, I have to have 4 to the 3/2, and here we're looking at the square root of 4 cubed, positive and negative again, and 4 cubed would be 64. Square root, of course, is 8, so this could either be positive 8 or negative 8, and that'll give us our 2 solutions. And we can check both of those solutions. They both do work. Okay, here, several different ways we could approach it. We want to find another way of representing that, so I'm just going to set it equal to x, and we want to basically figure out a different way to write x. And the reason I do this is because then I can use the definition of logs to say, what does this mean? Well, this base here, which is 10, raised to the x equals whatever's inside the log. So I can rewrite it as this equation, which is nice because then this 100, e to the ln 100 will just give me 100. Here's where a lot of people put 10 to the x equals 100 means that x equals 10. 10 to the 10th power would be much larger than 100. 10 squared gives me 100, so x is actually 2 in that case. So this original term right there would equal 2. On this one, first of all, before you start combining them to use the multiplication, division properties of logs, let's go ahead and pull those up into the power, because the property doesn't really let us combine these until we have log of something minus log of something. If there's some kind of coefficient out front, the rule doesn't tell us what to do in that case. So let's go ahead and get those powers up there, like I do right here. Then we can combine them. We cannot just multiply these two first. Why? We're going from left to right, and so first we want to combine these two logs into a single log, and then we're combining these two. They're linked by a sum. It's a sum linked by a addition there. So when we combine those, we multiply these two inside. Notice that when we multiply a fraction times some other quantity, we're just multiplying that quantity times the numerator, not numerator and denominator. Both of these would be acceptable answers. 8, I would start off by dividing both sides by 6. And now we could do it a few different ways. At this point, we could take the natural log, but if we take the natural log of both sides, we're taking the natural log of this entire product here, which means we would then separate it into ln 4 plus ln e to the negative 6x. We can't just put that ln straight inside here, just put it on the e. because that would ignore what happens to the 4. So that would be a possibility. I'm going to show a different way. I'm going to multiply both sides by e to the 6x, because that will allow these to cancel out. Why? Because when we multiply two quantities of the same base, we're just adding the power. Negative 6x plus 6x is 0. So we have e to the 0th, which is 1. 4 times 1 is 4. Over on the left, we're adding the 2x and 6x to get 8x. When we take the natural log of both sides, we can then pull the 8x out in front. Natural log of e is 1. And finally, we divide both sides by 8. There's a couple different ways of writing that. Ln 2 over 4. We could also have ln of 1/4 over negative 8, which would be, all of those are equivalent. Okay, this was probably the hardest question on the test, and it's actually a bit harder than I would like to give on a test, but because this was an exact homework problem that you had already, I felt that that was okay. This does provide a lesson that you should be working through the homework problems and letting me know if you can't figure out how to work one out before you get to the exam. The secret word for this video is elephant, and actually no, we already used that one. Let's do a different one, sorry. So the secret word for this video is orange. Orange, so make sure you write that down somewhere to get credit for watching this video. Okay, and what we want to do here is switch our x's and y's, multiply by 2x, and here's where we get into an awkward situation. So from here, I don't think there was anyone in the entire class that I've graded so far that moved forward correctly from here. So from this point, what we can do is get everything over onto the right side and then multiply by e to the y. Now, why would we do that? Well, that would give us something that looks like this, which doesn't look much better, except it may kind of look familiar to you because it's the same form as a quadratic. So what I'm going to do is just complete the square here. So notice that I'm grouping these two terms, and I'm creating my perfect square by taking 1/2 of this negative 2x, but then I'm remembering that I need this positive x squared in order to create this perfect square. So I add in that positive x squared, but I also have to add in the negative x squared so that I don't actually change the value of the right side there. And once I do that, these three terms get locked together in the perfect square, leaving these two out behind, and after that it's fairly standard algebra. But that one trick there of completing the square was a bit difficult. Okay, on 10, most importantly, you cannot distribute a log, so this cannot become log x plus log 12. We can use the rules of logs to combine these in this way. Once we have both sides as a single log and they're the same base log, we can just remove the logs because this would be the same as raising both sides to a power of 10, which would cancel out the logs. Once we get there, it's solving. Now here we do get x equals positive 6 and negative 6. The negative 6 is an extraneous solution because look up here, we could not have log of negative 6 in the original. Negative 6 would not be in the domain, and so because of that, we only keep the positive 6. We're going to run into a similar thing here, so number 11 is very similar to 10, perhaps even a bit simpler. The only thing we have here is there's a base of 2, so once we combine the two logs, we rewrite it using the definition of logs, so 2 squared gives us this. Squared is x squared plus x minus 2, and then solving that through standard methods, we would get negative 3 and 2. Again, negative 3 is not in the domain here because negative 3 minus 1 is negative 4, and we cannot have a negative log. So the only actual solution there is x equals 2. Okay.